Buckle up, everybody, because today we are diving deep into the world of AI that not only understands what's in a video, but also where and when things are happening.
It's like giving a language model eyes and a GPS and a time machine.
Yeah, I like that, a time machine.
All rolled into one.
It's wild.
It really is.
Oh, okay, let's break down this paper.
Yeah.
It's called LLaVA-ST, a multimodal large language model for fine-grained spatial-temporal understanding.
A mouthful.
It is a mouthful, I know. And, you know, it's hot off the presses, folks, published just this week.
Oh, wow.
January 14th, 2025. So this is cutting-edge stuff, and, you know, this research is making some serious waves in the AI community.
I mean, researchers have been working towards this kind of spatial-temporal understanding for years.
For years.
And this is really cracking the code.
Yeah, I mean, to give you an idea of the potential here, imagine AI that can instantly scan security footage and pinpoint, like, the exact moment a suspect, say, enters a specific room. Or how about this? Like, sports analysis software that can automatically break down every single play, highlight key moments, player movements, all with incredible accuracy.
Oh, that'd be amazing for coaches.
Right.
Yeah.
This is the future we're talking about here.
Yeah, it's about making this visual information accessible.
Yeah.
And understandable to AI.
And here's the thing.
Yeah.
The researchers actually had to invent brand new tests to challenge this AI because existing benchmarks, get this, were just too easy.
Oh, wow.
They found current AI models just couldn't even come close to grasping this kind of spatial-temporal understanding.
Yeah, current tests are very basic, like recognizing objects, describing static images, but they weren't designed to evaluate how AI connects information in time.
So where do we even begin with this? Like, what's the core problem these researchers set out to solve? What's missing from the AI world that LLaVA-ST is trying to provide?
Well, AI models are already very good at understanding images and text separately.
Separately, right.
Like they can recognize objects, generate captions, answer questions about pictures. But when you add the element of time, things get a lot more complicated.
It's kind of like, I'm thinking like the difference between, say, looking at a single photograph and watching a whole movie.
It's a good way to put it.
Right. Like a photo captures a moment, but a video is a whole sequence of events happening over time.
Exactly. So an AI might recognize, let's say, a motorbike in a still image.
Okay.
But it wouldn't be able to actually track its movement through a video.
I see.
Or understand, the actions happening around it in relation to time.
Right. It's like describing a whole football game to someone who's only seen snapshots of the players, not the actual flow of the plays.
Exactly. To really understand a video, you need to get the what, the where, and the when. And that's the big challenge that LLaVA-ST is tackling.
Okay, so how did the researchers pull this off? Like, what's the secret sauce in LLaVA-ST that gives it this groundbreaking ability?
Okay, so they introduced two key innovations. The first is something they call language-aligned positional embedding, LAPE for short.
LAPE. Okay, I'm listening.
Okay, so imagine trying to teach someone a new dance move.
Okay.
You can describe it with words, step to the left, step to the right.
Yeah.
But it's way easier if you could actually demonstrate the move, right?
Oh, yeah, for sure.
Words aren't always enough.
Right. Show, don't tell.
Exactly. LAPE is like giving the AI a shared language.
Okay.
For space and time.
I like that.
It can directly connect that visual information to language.
Okay, so instead of just recognizing motorbike, it understands motorbike at this particular location at this specific time.
Precisely.
It's like adding timestamps and GPS coordinates to everything.
Exactly. And this lets the AI understand how the visuals relate to their location and time within the video.
It's crucial for seeing the video as a whole dynamic thing.
Exactly.
Okay, so LAPE takes care of the where and the when, but what about the second innovation?
Okay, so that's where the Spatial-Temporal Packer comes in, STP for short.
STT, got it.
And this one helps the AI deal with the massive amount of information in a video.
Okay, break it down for me.
Imagine trying to summarize a 2-hour movie into a tweet.
Right, good luck with that.
Yeah, you just can't include every single detail.
You'd have to just say, things happened.
Yeah, exactly. So STP does something similar for the AI.
Okay.
It helps compress all of that visual and information from the video without losing those important connections, of space and time.
So it's not just randomly throwing information away.
No, not at all.
Okay.
It's very strategic.
Right.
It separates the compression of space and time,
Huh. Okay.
using this special attention mechanism
Okay.
to focus on the important regions and points in the video.
Got it.
It's kind of like how our brains naturally focus on the main characters in a movie.
Right. You kind of tune out the background stuff.
Exactly.
Okay. So it's like giving the AI a cheat sheet, the highlights of the video.
Yes, and this helps him make sense of all that information.
Okay, so LAPE gives the AI a shared language, and STP delivers the message efficiently.
Exactly. And then with all that, the language model can do amazing things.
Like the pinpointing, the describing, the tracking.
It's all in space and time.
Wild.
Pretty cool.
So how did they test all of this? Like, did they have to come up with new ways to see if LLaVA-ST was actually understanding these videos?
Yeah, they realized they needed entirely new benchmarks because, nothing like this had ever been done before.
Okay, so new tests, new benchmarks, how do they work?
Okay, so the first one is called Spatial-Temporal Video Grounding, STVG for short. Imagine you show the AI a video and ask it to point out the exact area and time something specific happens, like where and when does the chef add the secret ingredient?
Okay, I see. So it's not just about recognizing objects or actions, but actually connecting them to specific moments and locations in the video?
Precisely. It has to give you the timestamp and the coordinates on the screen.
Wow. No more vague answers?
No more somewhere in the middle.
Right, that's a tough test. What about the other ones?
Okay, the second one is called Event Localization and Captioning, or ELC, and this time you give the AI a starting point in the video, like someone getting on a motorbike,
Okay.
and it has to figure out where that event ends and give you a caption describing what happened.
So it's not just identifying the start and end, but actually understanding what's going on
Yes.
and being able to explain it?
Like writing a real-time report of the video.
Okay, that's impressive.
And the third task is called Spatial Video Grounding, or SVG. You tell the AI how long something lasts, and it has to trace the path of that object. Like, imagine giving it a time window and asking it to draw the route of that motorbike on a map.
Wow, so connecting the dots to get the full picture of the object's movement.
Yes. And these three tests together give a really complete look at how well the AI understands video in a spatial-temporal way.
Okay, so we've got this revolutionary AI, LLaVA-ST, and these super challenging tests. How did it actually perform? Did it live up to the hype?
The results were really impressive. It completely outperformed all the other AI models on these new benchmarks, showing a level of understanding we really haven't seen before.
Give me the details. How much better are we talking?
Well, we'll get into the nitty-gritty of the results in the next part of our deep dive, but let's just say that LLaVA-ST consistently beat the competition. Sometimes by a lot. It's not perfect yet, but it's a huge leap forward.
Okay, before we go any further, I want to bring this back to our listeners. Like, why should they care about this? How could this tech actually impact their lives?
That's a great point. This isn't just some abstract AI thing. LLaVA-ST could change a lot of fields we interact with every day.
Like what? Give us some examples.
Okay, let's start with security. Imagine analyzing hours of security footage in just seconds. LLaVA-ST could identify suspicious activities, track people, even maybe predict threats.
Wow, that would be a game changer for security.
And think about sports analysis. It could give coaches these incredibly detailed breakdowns of games, pinpointing key moments, analyzing player movements, even predicting outcomes.
So it's like having an AI assistant that sees the game like the best coaches do.
Exactly. And don't forget about accessibility. Imagine video captions that not only transcribe what's being said, but also describe what's happening visually.
Yeah, that would make videos so much more accessible for people with visual impairments.
And think about personal AI assistants. You could ask your AI to find the moment I blew out the candles on my birthday cake.
Or show me all the times my dog chased a squirrel.
Right. It could totally change how we interact with our own videos.
Okay, this is seriously impressive. So LLaVA-ST is a major step forward, but we've only scratched the surface here.
Yeah, we've got a lot more to explore.
In the next part of our deep dive, we'll get into the technical details of LLaVA-ST and unpack those incredible results.
Get ready to get technical.
Stay tuned, everyone.
It's about to get even more interesting. Welcome back to our deep dive into LLaVA-ST.
Right, I'm ready to go even deeper into this AI that can see in space and time.
Well, get ready to crack open the hood and see how LLaVA-ST really works.
Okay, perfect. I love seeing how things work. Where do we even begin with something this complex?
A good place to start is with the overall architecture. It's built on something called a multimodal large language model, MLLM for short.
MLLM. Okay, sounds fancy, but what does that even mean?
So think of it like a supercharged language model
Okay.
that's been trained not just on text, but also on images and videos.
Okay.
So it can understand information from multiple sources, not just words.
So it's like a language model that also went to film school?
Uh-huh. Yeah, something like that. And this multimodal training is really important for LAVA-ST because it needs to connect language to visual information in a really specific way.
Right. It's not just about seeing a motorbike. It's about understanding where it is in the video, how it's moving, what's happening around it at that exact moment.
Exactly. And to do that, LAVA-ST uses two main components, an image encoder and the large language model itself.
Okay, so the image encoder is kind of like the AI's eyes, capturing the visual stuff from the video.
Exactly. It analyzes each frame and pulls out the important visual elements like objects, their locations, and how they relate to each other.
So it creates a detailed snapshot of each frame.
Yeah, and then that visual information is fed into the large language model. That's where the magic happens.
Okay, this is where I get really interested. What does the language model actually do with all this visual data?
This is where those innovations we talked about, LAPE and STP, come into play. Remember, LAPE helps align the language and visual stuff.
Right, by converting those coordinates into text-based tokens.
Exactly. It's like translating those snapshots into a language the AI can understand.
Cool.
And then STP comes in and compresses all that information without losing the important connections.
Right, like a super efficient packing system.
Exactly. So LAPE provides the shared language, and STP makes sure the message is clear and concise.
I like that.
And once the language model has this processed visual info, it can use all its knowledge to perform those tasks we discussed earlier.
Pinpointing, the describing, tracking objects through space and time.
All of that.
It's amazing how all of this is happening behind the scenes.
It really is a remarkable accomplishment.
So let's zoom in on some of the technical details.
Okay.
What makes LLaVA-ST different from previous attempts at this kind of spatial temporal understanding?
One key breakthrough is how it handles spatial information. Instead of just treating coordinates as simple numbers, it uses something called language-aligned positional embeddings to represent them in a way that's more meaningful for the language model.
So instead of seeing coordinates 45, 127, it actually understands what those coordinates mean in the context of the video.
Exactly. And it does this by incorporating those spatial tokens into the language model's vocabulary. It's like teaching the AI a new language.
Wow, a whole new language for understanding locations.
Yeah, and this really impacts the model's ability to understand those spatial relationships.
Makes sense why they had to invent new tests for this. This goes way beyond just recognizing objects.
Absolutely. And they apply the same innovation to the temporal dimension as well.
So time isn't just a series of snapshots.
Nope. It uses temporal anchor points to divide the video into segments that match the natural flow of events.
So it's like the AI is picking out the key moments in the video where the important actions happen.
Exactly. And this lets it be much more precise, pinpointing events with incredible accuracy.
So it's almost like LAST is watching and understanding the video in a similar way to how humans do.
Exactly, focusing on the important moments and filtering out the rest.
That's one of the coolest things about this. It's not just copying human intelligence.
Right.
It's creating its own way of understanding that's both efficient and accurate.
Exactly.
So we've talked about LAPE and how it helps with the where and when, but we also mentioned STP, the Spatial-Temporal Packer, right? The thing that helps the AI handle all that information. How does STP work?
Sure. So STP uses a two-stream packing mechanism, compressing spatial and temporal information separately. It starts by reducing the spatial resolution of the visual features, using a combo of pooling and attention mechanisms.
So it's basically creating a simplified version of each frame, keeping only what's important.
That's right. And then it does something similar for the temporal dimension, focusing on those important time segments based on the temporal anchor points.
Okay, so it's like highlighting the key scenes in a movie, but still keeping the overall story intact.
Exactly. This separation helps STP to be more effective in keeping those crucial relationships between what's happening, where, and when.
So it's like the AI is learning to watch the video like we do, paying attention to the important stuff and filtering out the noise.
Yeah, that's a great way to put it. And the results of this are pretty remarkable. LLaVA-ST can process information in a way that's really efficient and accurate.
Okay, so we've seen how LLaVA-ST works, but how did it actually perform on those new tests? Give me the numbers.
Well, as I said before, it consistently did better than other AI models. It really showed how good it was at handling these complex tasks that need a deep understanding of space and time.
Okay, but give me specifics, like what were some of the highlights?
For example, on the Spatial-Temporal Video Grounding task, STVG, LLaVA-ST, got a mean intersection over union score, or MIOU, of 43.8%.
Okay, what does that mean in plain English?
It means that the area and time window identified by the AI overlapped with the correct answer by almost 44%.
And how did that compare to the other models?
Well, the best one before this only got an MIOU of 33%, so that's a big improvement, over 10%.
Wow, that's huge. It really shows how effective those innovations are.
Yeah, and it did similarly well on the other tasks. On event localization and captioning, ELC, it got an IOU of 60% and a meteor score of 24.7.
Meteor score, what's that?
It's basically a way to measure how good machine-generated text is, and 24.7 is pretty impressive for a task this complex.
So it was not only able to pinpoint when the event ended, but it also gave a good description of what happened.
Exactly, showing that it could understand the visual content and generate language that reflected its spatial temporal understanding.
Okay, so LLaVA-ST is clearly a big deal, but who are the brains behind this?
It was a team effort by researchers from Beihang University, Hefei University of Technology, the Institute of Information Engineering at the Chinese Academy of Sciences, and Meituan.
Meituan, the food delivery company.
Yeah, they've been putting a lot of resources into AI research lately, especially in computer vision and natural language processing, and they've built a really good team.
It's interesting to see a company known for food delivery pushing the boundaries of AI.
It is, and the lead author is Hongyu Li, a PhD student at Beihang University. It's always great to see young researchers doing such important work.
So what's next for LLaVA-ST and the team? What are they looking at for the future?
One thing they want to do is make it even more robust. Right now, it could be a bit sensitive to things like video quality, which can affect how well it performs.
So making it work better in real-world situations where videos aren't always perfect?
Yeah, and they also want to expand its capabilities to handle even more tasks. Right now, it's mainly focused on understanding events and actions. But they're exploring things like video summarization, question answering, even video generation.
So taking those core abilities and applying them to even more complex things.
Exactly, and of course, they're working on making it more efficient so it can be used on more devices and by more people.
That's important for making sure this technology benefits everyone.
And as LLaVA-ST keeps evolving, it'll be really exciting to see how it shapes the future of AI and how it impacts our lives.
Okay, before we move on to the final part of our deep dive, let's step back for a minute. What does this research say about AI today and what it could do in the future?
LLaVA-ST really shows how far we've come in AI, especially in multimodal learning. It shows that AI can understand the world in ways that we used to think were only possible for humans.
It's like AI is developing its own senses, its own way of experiencing the world.
And that's a really big deal. As AI gets better at understanding things like space, time, and human behavior, it's going to play a bigger and bigger role in shaping our future.
It could change everything, from how we work to how we entertain ourselves. The possibilities are huge.
And LLaVA-ST is a reminder that we're really just getting started. As research continues, we're going to see even more incredible discoveries that will change how we live and interact with the world.
Okay, we've seen how LLaVA-ST works, met the people behind it, and thought about the big picture.
Now it's time to look ahead.
Exactly. In the last part of our deep dive, we'll shift our focus to the future. We'll explore all the potential applications of LLaVA-ST and discuss what it could mean for our world.
Stay with us. It's going to be exciting.
Welcome back to the deep dive. We've been talking about this mind-blowing AI, LLaVA-ST, and I gotta say, the possibilities are, endless.
It really does feel like we're on the edge of something huge.
Right, we've covered a lot of ground, the tech, the results, but now let's really, open up and imagine, what could this actually do in the world? AI that understands video, not just as pictures, but as a story in space and time.
Yeah, it's not just seeing what's there, but understanding where and when it's happening, and that opens up so many doors.
So let's dive in. What are some of the most exciting, applications? Where do you see this making a real impact?
Well, even something as simple as searching for a video online could change. Like right now we use keywords, tags.
Right.
But with LLaVA-ST, imagine searching for specific moments within a video. Like the exact second a chef adds that secret ingredient or a basketball player makes the winning shot.
No more scrubbing through hours of footage trying to find that one moment.
Exactly. Video search could become incredibly precise and efficient.
Yeah.
That's just scratching the surface. Think about security and surveillance.
Oh yeah, hours and hours of footage, most of it nothing.
Right, but with LAVA-ST, we could analyze all that footage instantly, finding suspicious activity, tracking people, even predicting threats based on patterns.
Like an AI security guard that never misses a thing.
And it's not just about preventing bad things. Think about accident analysis. LAVA-ST could analyze traffic camera footage, find dangerous driving patterns or road conditions.
So using AI to prevent accidents before they even happen.
Exactly. And another area I'm really excited about is accessibility.
Okay.
LAVA-ST could create incredibly detailed audio descriptions of videos for people who are visually impaired.
That's so important, making information and entertainment accessible to everyone.
Exactly. And speaking of entertainment, imagine how this could revolutionize video games, movies, even virtual reality. Imagine a video game world where your actions have real-time consequences, analyzed and responded to by the AI.
Oh wow, that would be incredible, so immersive.
Right, and think about interactive movies or VR experiences that feel truly realistic and responsive. LAVA-ST could create a whole new level of entertainment.
Okay, I'm fully on board. The future sounds amazing, but we got to talk about the potential downsides too, right? Like
Yeah.
new technology can have unintended consequences.
You're absolutely right. We have to think critically about how this could be misused or even abused. We need to have those tough conversations about responsible and ethical development.
Yeah, it's about finding that balance between progress and responsibility, pushing boundaries, but also protecting against harm.
And it's important to remember that AI is a tool. It can be used for good or bad. It's up to us to make sure it benefits everyone.
So as we wrap up our deep dive into LAVA-ST, what's the key takeaway you want listeners to remember?
LAVA-ST is a huge achievement. It shows what's possible with AI. It's a powerful tool that could change so much about our world.
But with great power comes great responsibility. We need to approach this with excitement and caution, harnessing its potential for good while being mindful of the risks.
It's a really exciting time, and I can't wait to see what happens next with LAVA-ST and all these other incredible AI advancements.
This has been a wild ride into the world of AI that sees in space and time. Thanks for joining us on the deep dive. We'll see you next time.